Hello friends, welcome to my channel Academic Made Easy PC. So in the previous video I gave you the introduction for functions, and in this video we'll be learning exercise 1.2. So first sum. Show that the function f from r star to r star defined by f of x is equal to 1 by x is 1 to 1 and onto, where r star is a set of all non-zero real numbers. So this is the first part of the question. Second part says, is the result true if the domain r star is replaced by n with codomain being same as r star? So domain is changed. It means this r star will be changed to n in the second part of the question. This is second part of the question. So first we'll prove the first part, then we'll move on to the second part. Have written what all is given. Given here is that function from r star to r star. R star here represents set of all non-zero real numbers. Real numbers minus 0. Only this is 0. So non-zero means except 0. So I have taken like this. R minus 0. Okay. So then we have to prove that f of x is 1 to 1 and onto. 1 to 1 means injective, onto means surjective. See the proof part. Okay, let x1 and x2 belong to r star. Okay, so next step I'm writing f of x1 is equal to f of x2. So what is the given f of x here? 1 by x, isn't it? So I will write here as 1 by x1 is equal to 1 by x2. Okay, so when I cross multiply here, so I will get x2 is equal to x1. Rewriting it, I will have x1 is equal to x2. Therefore, the condition is satisfied. So therefore, I will say f of x is 1 to 1. That's it. It's very easy. 1 to 1. Only so much. So let x1 comma x2 belong to R. F of x1 is equal to f of x2. Then substitute f of x, and at last we will receive x1 is equal to x2. Okay. So now we'll see for onto. For onto, we have to write for every x belonging to R star, there exists y belonging to R star. So I'm saying like R star to R star, isn't it? I'm taking the domain as x and codomain as y. So y x to y. Okay, so let's start now. So I'm assuming that f of x is equal to y. So what is f of x? 1 by x, isn't it? 1 by x is equal to y. So now I have to get x in terms of y. So what will I do? I will take reciprocal or cross multiply. Okay, so I'll take x over here and y over here. So I will have 1 by y is equal to x, that is x is equal to 1 by y. I got the value of x. Okay, so now I will check whether f of x is equal to y or not. Okay, so f of x is equal to, what is f of x? 1 by x. Why did we do this part? Because we have to get x in terms of y. Okay, why are we doing this part? To get the answer as f of x is equal to y. If we get f of x is equal to y, then it is onto. If not, it is not onto. F of x is equal to 1 by, what is x value? 1 by y, isn't it? 1 by y. If we take reciprocal, we will have f of x is equal to y. Hence, this is the required condition that we got it. Therefore, I will say that f is onto. Okay, so by this first part of the question gets over. We have to do with the second part. What they are saying, the domain is changed to n. That is, r star is changed to n. So therefore, we'll have function n to r star. That's it. Function from n to r star. R star is nothing but r minus 0, isn't it? I already said you. So now we'll check for 1 to 1. There also they asked us to check whether it is 1 to 1 and on to, isn't it? So I'm taking this one. So for 1 to 1, I'm taking let x1 comma x2 belong to n. This is domain, no? So f of x1 is equal to f of x2. 1 by x1 is equal to 1 by x2. Therefore, x1 is equal to x2. So, therefore, f is 1 to 1. Okay, so now we'll check for onto. This is also same thing. For every x belonging to n, there exists y belonging to r star. This is very important to be written. So f of x is equal to y. Okay, so 1 by x is equal to y. So x we will get it as 1 by y. But for example, if we take minus 3 belongs to r star, isn't it? But what is our domain? Natural numbers. So natural numbers means it starts from 1, 2, 3, etc. only. The codomain I have minus 3, but in the range I will not get minus 3. Therefore, there is no element in n such that x is equal to 1 by y in r star. Therefore, it is not onto. Okay, natural numbers is always positive. Can we get negative numbers in real numbers? No. Real numbers, they are saying non-zero real numbers. So, it might have negative also. But here, no negative. Second question, check the injectivity and surjectivity of the following functions. Injectivity means 1 to 1, surjectivity means on to. Function from n to n given by f of x is equal to x square. Now I have written function from n to n and f of x is equal to x square. So now we'll go with solution. First we'll check for 1 to 1. I'll write let x1 comma x2 belong to n. Okay, so I will have f of x1 is equal to f of x2. So what is f of x? X square. So x1 square is equal to x2 square. So x1 is equal to x2. Just take a square root on both the sides. So we will get this answer. Okay, so therefore I will say f is injective. Done. Next, onto. For every x belonging to n, there exists y also belonging to n. Therefore, we'll have f of x is equal to y. So, f of x is x square is equal to y. X is equal to root y. Okay. So, for example, if we take 2 belongs to n in the codomain or a domain as well as codomain. Domain and codomain. But Root 2 does not belong to n in domain as well as codomain. So if I take x as 2, then root y will be root 2, isn't it? So therefore, I will say that f is not surjective. Surjective. Second subdivision, f from z to z, that is real numbers, given by f of x is equal to x square. I have written function from z to z and given f of x. So solution, first one, 1 to 1. So let me write, let x1 comma x2 belong to z. Therefore, I will say f of x1 is equal to f of x2. So what is f of x square? X1 square is equal to x2 square. So x1 is equal to x2. But in case, for example, if I take x1 as minus 1, okay, x2 as 1. So minus 1 the whole square also is 1. 1 square also is 1. So that is not 1 to 1. Okay, in the domain I have minus 1, etc., 0 and 1, etc. Okay, this is the function, good domain, and let me have 0, minus 1, etc., 1, etc. So minus 1 square also is 1, 1 square also is 1. So is this many 1 to 1? No, it is many to 1, isn't it? So therefore, f of x is not injective. Not injective. Okay, whatever number we take, minus 2 square also is 4, 2 square also is 4, isn't it? So we won't say that it is 1 to 1. So now we'll move on to for every x belonging to z, there exists y belonging to z. Okay, so f of x is equal to y. So x square is equal to y. So x is equal to root y. But in case if minus 1 belongs to z, okay, does root of minus 1 belong to z? No. Therefore, root of minus 1 does not belong to z. Therefore, we will say that f of x is not surjective. Not surjective. Subdivision 3, function from R to R, real numbers, given by f of x is equal to x square. First 1 to 1. Let x1 comma x2 belong to R. F of x1 is equal to f of x2. x1 square is equal to x2 square. x1 is equal to x2. But if real numbers means both positive also is there, negative also is there. Okay, so minus 1 square, example, minus 1 square also is equal to 1 and 1 square is also equal to 1, whereas minus 1 is not equal to 1, isn't it? So therefore I will say f is not 1 to 1. Okay, this is clear. On to, for every x belonging to R, there exists y belonging to R. Okay, so for this, for f of x is equal to x square, y is equal to x square, then x is equal to root y. Okay, for every y belonging to R in the codomain, there is no x such that x is equal to root y. Why? Because for example, minus 2 belongs to R in the codomain. But root of minus 2 does not belong to R in the codomain. Therefore, f is not on 2. Okay. Subdivision 4. Function from n to n natural numbers given by f of x is equal to x cube. Solution. First 1 to 1. Let x1 comma x2 belong to n. Natural numbers, isn't it? F of x1 is equal to f of x2. F of x is x cube. So x1 cube is equal to x2 cube. So therefore x1 is equal to x2. So since there's no negative numbers in natural numbers, we need not to worry. Therefore we will write f is 1 to 1, that is injective. Okay, now we'll move on to. For every x belonging to n, there exists y belonging to n. Okay, so f of x is equal to y. X cube is equal to y. X is equal to cube root of y. Okay, so for example, if we take 2 belongs to n. Okay, but cube root of 2 does not belong to n. Therefore, we will say that f is not on 2. If you want to write the statement that I gave for the previous sum also, you can write, or just if you write 2 belong to n and but 2 cube root of 2 does not belong to n, that also is correct. Okay. Function from z to z integers given by f of x is equal to x cube. First 1 to 1. Now I am writing, let x1 comma x2 belong to R. So therefore f of x1 is equal to f of x2. Therefore x1 cube is equal to x2 cube. Therefore x1 is equal to x2. Even if we take the example C, minus 1 cube is equal to minus 1. 1 cube is equal to 1 only. So it is 1 to 1 only, no? So therefore f is 1 to 1 or injective on 2. For every x belonging to z, there exists y belonging to z. So therefore f of x is equal to y. X cube is equal to y. X is equal to cube root of y. Okay. Now, for example, 3 belongs to z. Minus 3 belongs to z. But there is no cube root of minus 3 belonging to z. No. Therefore, f is not surjective or onto. So now let me introduce a new concept for you all. Greatest integer function. Greatest integer function means nothing but, for example, x is equal to 2.3. If I have here, so greatest integer function means the x will be represented in this way. Okay, greatest integer function is equal to 2. We will be truncating this part and writing only this part before the decimal place. Okay, so even if x is equal to 2.9, we will be writing x is equal to 2 only. It is not rounding off. We are taking only the number which is before decimal point. Okay. Question number 3. Prove that the greatest integer function from R to R, that is real numbers, given by f of x is equal to greatest integer function of x is neither 1 to 1 nor onto, where x denotes the greatest integer less than or equal to x. Solution. I already taught you what is greatest integer function, isn't it? So directly we can go to the solution. First one is on 1 to 1. Let x1 comma x2 belong to R. So f of x1 is equal to f of x2. So therefore f x1 is equal to x2, that is greatest integer function. So can we say that x1 is equal to x2? No. This greatest integer function may be equal, but x1 is not equal to x2. For example, x1 is equal to 3.5. x2 is equal to 3.2. So the greatest integer function of x1 is equal to x2. If we take 3 is equal to 3 only, but is 3.5 equal to 3.2? No, not at all. Therefore, it is not 1 to 1 onto. For every x belonging to R, there exists y belonging to z is an integer. Therefore, f is not onto.